Good afternoon, everybody. Welcome back to the interview prep session. My name is Swanindra. So I've seen that we've received some good response from the candidates. So I thought I'd revisit a few of the important questions that we did in the first one, that I did in the first one. So we'll do a sort of revisit, and then we'll take a look at the questions that were asked previously. As always, I'll keep an eye out on the live chat, and I'll be looking out for interaction answers. And like always, I'll pose the question, type it down, give it a few seconds, uh, and then wait for answers, etc. And then I'll provide the answer myself. So thank you once again for joining us today. Hey Sanjay, good afternoon. Good to have you here. So like always, I'm expecting on point answers. And like I said, it's good to have you here. And I'm also keeping an eye out. At least I'll try to keep an eye out. And we'll get started. So I'll say, what are some important steps to be taken for data cleaning before any algorithm is applied? So I asked, what are some steps, important steps to be taken for data cleaning, etc. For before any algorithm is applied, before even think about applying a few algorithms, what are some things that we'll have to do? Hey, good afternoon, Sachin. Good to have you here. We just got started. I'll give it a few seconds and then you can, yeah, missing values, you mean? Uh, this is a, this is just an interview prep session. We'll get you familiar with the sort of questions that you might get asked in an interview. And this is just something for you to, stay on your toes. So that is the aim of this webinar. Outliers, okay. I see some good answers. Outliers, missing values, etc. Outliers should be treated. Understand the business problem, okay. Okay, so I'll go ahead and put down my answer, and also overall, great answers in the chat. So like no wrong answers anywhere. So I'll say, for the sake of completeness, I'll say structuring the data. And in the case of semi-structured data, etc., maybe it's not in the format that you want. And then handling missing values. Then standardization or standardization or normalization. Standardization, okay. Normalization. We can do some data visualization. We can do some feature engineering, etc. So these are some steps that you can take before we get to thinking about what algorithms to use. I mean, we will already have an idea in the back of our minds about the type of data or what algorithm would fit the type of data we have. But before all of that, we'll have to take a look at, these things here. Good answer so far. So next question is, so since here we brought up the topic of visualization, so I'll ask, what are some quick quick plots for visualization? So before you go to Tableau and do all of the proper dashboarding stuff, for your own sake, while you're working on the data, you're doing some EDA, etc. What are some quick plots that you can use to gain a sort of at a glance understanding of the data? Yeah, QQ plot. ggplot is the package. Yeah, QQ plot to check what exactly? Okay, so you said QQ plot. What is a QQ plot used for, and what does QQ stand for? This is a sort of just an additional question to test your this thing. I'll even put it down after I ask this. So I asked, what are some quick plots for visualization? Yeah. Okay. So once again, solid answers, right answers. Yeah. So some plots are box plots, histograms, bar plots, and scatter plots. So your answers have given me another interesting question to ask. So I'll ask, what is a QQ plot? Great, great. What does it stand for? Just another added part to that. Yeah, so I see some answers here. Yeah, it stands for quantile quantile. So basically, so I'll say it's let me. It stands for quantile quantile plot. It is used to compare. No, it stands for quantile quantile plot. Maybe putting this will not give us the error. So it is used to compare different distributions and to see if they come from the same underlying distribution. So usually we use it to check normality because we compare the quantiles of a standard normal distribution to the data that we have. In our specific case, we use QQ plot for checking normality. I mean, if it's standard normal deviation or not. But in general, it is just used to compare different distributions by mapping the quantiles, the respective quantiles in the plot. And if it forms a straight line, we can tell that they come from the same sort of underlying distribution. So that is the logic behind QQ plots. Oh, grammar of graphics. Okay, great, great, nice. That's another it's a tiny fun fact. So thanks for adding that. Who said that? Pritesh. Yeah, thank you very much. That's a neat fact to know. I myself wasn't aware of that. Good answers, guys. Good interaction. So I'll ask. So in second question, I said, what are some quick plots for visualizations? Now I'll ask, and this is a simpler question than the others. Which of the plots in question 2 can be used to understand the direction and to an extent the strength of correlation in bivariate analysis? So I asked, which of the plots in question 2 can be used to understand the direction and the strength of correlation in bivariate analysis? Yeah, scatter plot. Absolutely right. So the answer is scatter plot. Quite a few participants today. Um, this is great. Great to see all of you respond. And good to have you all here. Yeah. Yes, Kritesh. Also, yeah, using pair plots, we can analyze the data. Also, and this is just an added question, what package allows us to do a quick pair plot this thing with just just a single line of code? So I see SNS dot pair. Yeah, okay. If you import that as SNS, then yeah, see SNS dot pair plot. Right. Yeah. Seaborn has a function for that. How can you get these notes? I'm not sure. We haven't. I mean, I haven't discussed the sharing of notes and all, because this is just something that I use as a visual tool so that I can ask a question and then type it at the same time, so that you can have enough time to understand what I'm asking, and also I say the answer out loud and then type it again for the same effect. GG Ally in R. Okay, that's great. It's been a while since I've checked functions in R, so thanks for adding that extra needle fact. So Neelam tells me GG Ally in R will do the same thing, which is great. So if any of you, if you didn't know, neither did I. It's good to note. Okay, so since we talked about correlation, strength of correlation, we'll have to talk about something. I'm not going to give away the answer, so I'll ask what metric is used to get the exact idea about the strength of correlation. So I asked what metric is used to get the exact idea about the strength of correlation. Yeah, so I see an answer here, Pearson's correlation coefficient. Euclidean is a distance metric. That is a distance metric, Euclidean distance. The root of difference of x squared plus difference of y squared, etc. Yeah, correlation coefficient, Pearson's correlation coefficient. I'm sure there's another one. There's probably another type of correlation coefficient which I can't seem to remember right now. Yeah, the correlation matrix comes from calculating using the Pearson's correlation, and then you just put it in the form of a matrix, and it'll give you the correlation matrix. So usually it look like what 0.9, 1, 1.9 or something, right? That is calculated from the Pearson's correlation form. So all around correct answers again. Something called the correlation coefficient. Also, as an added question, what function do you use in Python to get the value of the correlation coefficient? Package and function. Yeah, so Neelam, covariance, I mean, you're not wrong. It's just that covariance is used along with, I think it's the standard deviation. Covariance is first determined for calculating Pearson correlation coefficient. So I mean, covariance shows up in the Pearson correlation formula. Uh, Looks like we have an R expert here. It's not often that people answer in R related questions. So that is great. Also, somebody answered. Who answered? Um, I see. Oh, Sukamal. Yeah. So, core from pandas will do like a pairwise correlation. But simply the one that we've used in our classes, if you remember, yeah, sort of, yeah, that's. I mean, it's not like that's the only thing I was looking for. NumPy has a core coef function that'll give you that correlation matrix. Somebody mentioned, right? Who was it that mentioned? So Paresh mentioned a correlation matrix. So that NumPy np dot core coef will give you that matrix, the correlation matrix. So what metric is used? I'll also quickly ask what are the range? What is the, I mean, I'm sorry, what is the range of values taken by the correlation coefficient? What is the range of values taken by the correlation coefficient? Vishnu, are you sure? 0 to 1 is if you don't consider the direction, but it actually goes from -1 to 1. Sukamal. Yeah, I mean, if we're talking about the absolute values, then yeah, you can say, you can say it's 0 to 1. But since direction is also a factor, there can be positive correlation and negative correlation. Yeah, so it'll include the negative values also. Yeah, no problem, Paresh. It's just a matter of direction, that's all. Otherwise, the absolute value, the mod value of that is the same. It's either it's only for us to know if it is decreasing or increasing, if the slope increases or decreases. So yeah, you have the general idea, so that is okay. So I'll go ahead and put it in the thing. I'll put the answer. So I was saying the range is also important. No, I mean the direction is important. Sorry, that was totally my bad. I meant the direction is important. If we're not talking about direction, then you can say that it ranges from 0 to 1. But since direction is also an important consideration, we'll have to include the negative values also. So we'll say the range is -1 to 1, with 0 being the least. 0 being the least value for correlation coefficient. for the correlation coefficient. This thing keeps me on my toes all the time, so that's good. So that is the values taken by the correlation coefficient. I'll say, what is the issue of imbalance in data sets? Data sets. What's the issue of imbalance in data sets? What do we mean when we say there's an imbalance in data sets? Yeah, so no correlation between the data, that is zero correlation. You're right. It's basically noise. You cannot, get an idea of the movement of one variable with respect to the other because they're not correlated. It's basically noise. Yeah, so Sukamal, right? Once again, target classes, they're not in equal proportion. So we can say, the target classes are not represented in equal proportion in the data set. So what are some issues that might arise because of this imbalance? Yeah, so accuracy will take a hit. There'll be a sort of bias that'll be created in the model because it only sees a lot more of the majority classes and not enough of the minority. Exactly. Sukamal has the right idea. I mean, as does everybody else. So I just meant that model will that he put it in a way that I was going to say myself. So I meant, yeah, model will not learn enough about the minority class. It'll learn way more about the majority class and not enough of the minority class. So it can sort of uh, lead to overfitting also. And underfitting, yeah, because there isn't enough data at all relating to one class. So once the test data comes in, once data it has never seen comes in, then that'll be an issue. So that'll be an issue there. So yeah, that is, yeah, when we do train test split, first of all, there's just fewer class. I mean, there's a minority class. On top of that, when you split and you use even lesser data, I mean, even lesser classes in the training of the model, it'll lead to a huge this thing bias. He'll basically look like a near zero variance or zero variance columns. If you remember, way back in CRISP DM, we saw it features having near zero or zero variance. So that is something that might happen. So if it is near zero variance, it just means that it's a useless column. It doesn't add too much value to our model. So that can be an issue there. So this is a nice place to ask this question. I'll say, what is the bias variance trade-off in machine learning? What is the bias variance trade-off in Yeah, so random splitting, when you do train test, it is actually in fact done randomly only. That's why when you keep running the model again and again, the accuracy metrics change, because when you do train test it does do it randomly. We might have to do some sort of cross validation or take more samples containing the minority class, and fewer samples containing the yeah. So once again, right answers. The tension between I mean you both of you have the right this thing. We'll wait just another second or two to see if somebody else will jump in. So there you have the answer. So next question is, what are L1 and L2 regularizations? What are L1 and L2 regularizations? Yeah, Lasso and Ridge regularization methods. So basically, L1 is called Lasso and L2 is called Ridge regularization. So basically, if you know, in general regular regression, we minimize the minimizes. We minimize the squared errors, but in regularization, there's an added term here. So the term is what exactly? Has anybody put? Okay, yeah. So basically, what it does is there's an added term. It's the square of the slope. of the regression line. So we'll say, L2 regularization minimizes the squared residuals and also another term called lambda, which is the square of the slope of the regression line. Replacing the square of the slope with the absolute value of the slope will give us L1 regularization. So it's a sort of, you can think of it as, penalty. Yeah, so I'm looking at the answers and all splendid answers and on point too. So I see that you've been paying attention in class and doing a little bit of your own this thing, which is great. So next I'll ask, what is cross validation, and what are some methods in cross. I apologize. Cross validation. What is cross validation and what are some methods in cross validation? So if you don't know, there's a bit of a lag between me doing it here and then it showing up in the YouTube live feed. So this is why there are some awkward pauses in the middle, and that is when I'm just looking at the answers and seeing if there's any response, etc. So that's what those pauses are. So thank you for bearing with me. Yeah, so I'm seeing some answers again. You're right. Cross validation is, it'll tell us how well our model can generalize. Some methods are, k-fold cross validation, leave one out, leave p out, stratified k-fold. So I'll start writing here. I think we've gotten 2 answers. Yeah. So cross validation tells us how well our model can generalize to data it hasn't seen. So that's what cross validation is simply, so some methods are 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 k-fold cross validation, where where data is you can say it is divided into uh, you know k sub subgroups, subsets, and k minus one of them are used for training, and the kth subset is used for validation and repeat. So that's what that is. And there's something called the stratified k-fold cross validation, which is basically like k-fold. But what we do here is we take a little care in seeing that so this is what we do for majority minority classes, etc. If there's the presence of these, or there's some imbalance, some slight imbalance maybe. So here what we'll do is we'll make sure that the subsets have the more or less the same percentage of each target class, same as k-fold, but we also make sure that each of the folds has the same percentage of the target class. The target class as the original data set. Okay, that is stratified k-fold. Okay, then there's something called the leave. I'll put it in this thing. Leave p out cross validation. This is where a data set has say n data points. Say the data set has n data points, and every time we set aside p and use n minus p to train. We set aside p data points and then train the model on n minus p data points, and then use the rest and use the p to validate for validation. So that is that. Good responses. Optimum values for parameters such as learning rate, etc. I'm not sure exactly what you mean. We can use something called the grid search or the random search, where we give it, we give it a range of values, and either it'll do an exhaustive search or it'll do a random search for the best hyperparameters. It's called hyperparameter tuning. So that's where we'll get good values for learning rate, and even in the case of decision trees, how many samples it should have per leaf, etc. All of that. But yeah, so all of you have the right general idea, so which is great. And okay, now a simple statistical concept. What are precision and recall? And bonus points if you can tell me why these are even important. Yeah, correct. So to specifically understand where we might make a mistake in classification, where our model might make a mistake in classification. So I'll say recall tells us what proportion of the actual positives were identified correctly. So that'll be what proportion of actual positives. So we'll say that'll be true positive divided by true positive plus false negative, which means it was actually positive. But our model said, that it isn't positive. So which is something called a false negative. So if you can see here that it makes sense, right? What proportion of the actual positives were identified correctly? So what we classify as TP, true positive, out of a mixture of both true positive and which were supposed to be positive but our model called negative. So that's what this means here. True positive by true positive plus false negative. And precision, what about precision? It is simply precision is what proportion of positives were correctly identified. So this will be what? True positive by what? True positive plus false positive. Out of all the positives that our model has identified, how many were actually correct? So how many types of positives are there? There's true positive, false positive. So that is what recall tells us. Important metrics to understand. And so next I'll ask, what is PCA? And once again, bonus points if you can tell me, the sort of logic behind that, the sort of understanding behind that. Principal dimension reduction. Okay, that's a mixture of PCA and dimensionality reduction. Okay, exactly. So they are like linear combinations of features. Basically, a vector is a linear combination of bases. Bases are things like our principal axes, like x-axis, y-axis, z-axis. So x, y, z will be our basis. So any vector is actually a linear combination of the basis. So the specific vector that we talk about here in the case of dimensionality reduction is something called the eigenvector. And it has something called the eigenvalues associated with that. So it is not simply just a linear combination of features. It is linear combination of features relating to the eigenvectors. That's what separates the usual data from, the principal axes. The eigenvectors give us the direction of, maximum variance. It'll tell us, which axes in a higher dimension capture most of the variance in the data, which is basically what we want. We want to capture as much variance as possible with as fewer features as possible. So that's what we want to know. So there's eigenvectors, eigenvalues, and somebody has said it's a linear combination, which is exactly what a vector is. So that's great. So I'll say PCA is a dimensionality reduction technique. It depends on things like the eigenvectors and eigenvalues. So these eigenvectors give us the direction of maximum variance, which is exactly what we want. So to reduce the number of features in our data, so it is used in compression, and basically reducing the demand or say load on memory and time, and basically speed up algorithm performance. If you think about it, it's the same thing, but it pays to sort of spell it out. So these are the things that it is useful for. And before I realized it's 4 o'clock, so I did not even realize the time passing. Thank you guys. Thank you very much for participation. Your answers are pretty much spot on every single time. And a few of you have given us some cool little factoids, you can say. And SVD, yeah, singular value decomposition. That is also a type of dimensionality reduction. It isn't exactly similar to PCA, but it is also a form of dimensionality reduction. If you've done recommender systems, you will know that you'll know how like SVD works. So that is great. So I'd like to thank you all for joining us today, and I hope you've learned a few things. And as always, it's a great pleasure to have you all here and to look at your answers and interact with you. And I hope you have a good rest of the week.